Good morning. We are going to talk about Project 3 for CS291A. So in this project, you will be writing a chat server and a corresponding React front end. React is a JavaScript framework for writing in-browser front ends, or sometimes referred to as single-page applications. They don't have to just be single-page. Your chat server will use Sinatra again. So you can kind of leverage the Docker container that you made for the last one to build your Sinatra application. And you will write a standalone React-based front end for your chat server. I have some instructions for how to develop using Docker so you don't have to set up an environment locally. That's up to you to use. I have provided a implementation, a deployed version of the chat server at chat.cs291.com that you may use, and your client should be able to communicate with this particular server. When I refresh, you'll note that the login tells me what chat URL to use. So this is just a front end that can communicate with this particular URL, but it should also be able to work with the server that you implement. So I provided the server and a front end. The front end, while this is being served by the server, there's another version of it that is separate just to show that they don't need to be associated, which is here. So this is hosted, and it's the same interface essentially, but this one I've separated out the files, so it's a little bit easier to see what's there, and I provided the source code, so you don't have to look at it in the browser. Okay. In this project, you have the option of working in pairs. I strongly recommend you do so unless you already have a fairly significant amount of React experience, because for many of you, this may be your first time learning JavaScript and first time working with React, and that can take some time on its own. Inevitably, what you end up writing won't be terribly complex, but the time to learn JavaScript and work on that, it may be easier to work in pairs. Now, one thing to note is you will have 2 weeks to work on this project, so more time overall, but it's going to require quite a bit. Should you work in pairs, you need to let me know by next Tuesday at 11 a.m. Who your pairs are going to be. And then once you've decided that you're going to work in a pair, I need you to commit to that pair. Barring extraordinary circumstances, the two of you will work together, and you'll either get 100% together, or we'll keep working at it until you get 100% together. Okay. Should you decide to work solo, either whether or not you're working in pairs or solo, please let me know, just so I have a record of everyone. And if you say you're going to work solo, you don't have to commit to that. You have up until next Tuesday to decide to merge with someone if you want to. But you need to message me on Piazza either way. I state here that I estimate this project to be about 4 times more complex than Project 2, factoring in the fact that you have to learn JavaScript. So if you know JavaScript, JSX already, then it may not be that much more complicated. You'll have to potentially learn new parts of Sinatra in order to get things to work. Okay, so this due date, 11 a.m. Tuesday, October 29th. If you looked at the schedule previously, I've actually extended this a little bit because I made the project slightly more complicated than I originally intended. So the learning outcomes for this project, you've written and deployed a React application coded using JSX. JSX is a particular language, essentially, that allows you to combine JavaScript and HTML, which makes writing React applications really awesome. So because you will be needing to support JavaScript clients that are not hosted on your own domain where your server is, or my domain, you will need to work with CORS headers. So there's a link below about CORS and what those headers are. So you'll have to kind of have an understanding of how that works in order to properly support that. So make sure you test your server using maybe the reference implementation to see if things work. And you can always check the JavaScript console to see if there's a particular issue with cores because it'll output doesn't have access or something. And then the way we're going to provide the real-time notifications, like not just notifications, but real-time messaging that comes in, is we're going to use this thing called server sent events. And the JavaScript piece that goes along with that is called the event source. And that'll allow the server to push out notifications or messages, events, to the browser using a persistent HTTP connection. An alternative approach would be to use WebSockets, but then you need to have a server that supports WebSockets, and server sent events works in most HTTP servers and application servers. Okay. You'll have the standard form submission, but there are 3 different deliverables this time, and I'll need a URL for each of them. So you'll need to push a Docker container that has the packaged version of your server that if I run docker run and give it your server name with the right other arguments, but not having to specify a script to run, your chat server automatically starts up and is listening, preferably on port 3000, but it could be a different one if you specify it. I will need a URL to your deployed front-end application that includes minimized JavaScript. And tip, you don't have to do anything special for that. Yarn build should create that for you, but you need to take what it creates and deploy it. Essentially, once it creates it, you have a static web application or set of resources that can be deployed statically. So you should be able to leverage Project Zero knowledge to get that deployed. And then I will need a repository containing your front-end source code. And if it also includes the server code, great. That repository should be private, so it's shared between you and your partner. But since it's private, I will also need access. So please invite me or add me. I only need read access, so you can invite me as Bebo on GitHub. And if you want to do that sooner, then I can check on your progress. And if you have questions, I can look at I can directly look at your code if you have issues. Okay, the server specification has 4 endpoints, I believe. Nope, just 3 endpoints. So fewer endpoints, but they're definitely more complicated. So because we're building a chat server, it's important that we're using HTTP, but we're going to kind of violate the traditional HTTP protocol in that this is going to be stateful. There are a couple of ways to maintain your state. The way I recommend doing it is run your web application entirely in a single process and then use essentially global variables to store that state. And so Sinatra supports that if you use the right front end. So Puma, in theory, should support it, assuming you only have 1 worker deployed. If you have 2 workers, then remember that they won't have shared memory. And so you might have 2 separate instances of your chat server running, which could be problematic, or would be problematic. You're free to add more endpoints to support additional functionality, but the caveat being is your chat front end still needs to work with my server backend, and my front end needs to be able to work with your server. So if you want to add additional support that if the server provides it and the client supports it, that's great. Like special slash messages or something, that'd be really cool. Make sure to mention that. But it definitely, nothing should be broken if I connect to my server. Okay, one note with this reference. Sections indicate reference are not things that you're required to do, but I am specifying them because when you look at the HTTP responses coming from the reference implementation, you might wonder, why am I getting this? So I'm specifying what the behavior is there. Um, I've intentionally, from the examples for curl and in particular the responses, I've excluded the CORS related headers because I want you to figure out what headers are necessary. So if I showed them, it'd be a little bit too easy for you to just be like, oh, I need to put these headers in. So this is an example, like curl doesn't require CORS because it is not an in-browser library. So it doesn't actually require the CORS headers, but browser-based, because of the browser single origin policy or cross origin, it tries not to send resources across requests unless they're explicitly granted, and that's what CORS is for. Okay, the endpoints. So the very first thing is login. So as you can see from the interface, there's a username and password. So that will interact with login. And you will post using a form input, so username and password. And on success, this is kind of like project 1, you will get back a JSON body with a signed token. This token doesn't necessarily need to be JSON web tokens, but you will need to verify that token and use it to identify the user when they send messages or try to connect to the stream. If the username and password combination doesn't match that of an existing user, it should be 403. And if either of those fields are blank, it should be 422. I explicitly check in the reference implementation that only username and password are passed in, and so I return 422 if any additional arguments are passed. So that's the reference implementation. This chat server does not have HTTPS in front of it. I didn't feel like setting that up. So do not actually send real passwords because they will be sent in plain text. You might ask, why is there not a register? So the way I've implemented this on the server is not the way you would really do it. But the first time, if a user does not yet exist in the system, then the first username and password combination, or the first password they send for that user, basically implicitly registers a user and then logs them in. So the first time you log in, or try to log in as a user, it'll create the user. And then on subsequent times, because the server's stateful, it'll only allow that password for that particular username. You can either implement a second register if you want. That's totally up to you. But just remember, your front end needs to work with my server, and my front end needs to be able, well, I guess if my front end needs to be able to work, well, as long as there's accounts already created and I can use my front end to log into one of those existing accounts, I don't care if the registration piece doesn't actually work. Okay, so this is curl example for how to log in, which either could create and log in or just log into an existing account. And the response has the token. You've seen this before, so that should not be too complicated. That should not be new. Post message. So if it's successful, 201. If the signed token is not valid, i.e. it doesn't match an existing user, 403. 422 if the message is blank. And then I expect there to only be the field message. So if any other fields show up, I get a 420. You get a 422, or if message isn't there. In order to authorize, just like in project 1, you're going to send the authorization header with bearer and then that particular token obtained from login. Okay, so this is an example. You have the URL /message, message test. So this is the form parameter, and then I'm passing the header. And the response is simple, 201 created on success. So this is the interesting part. This is where we use server sent events, and you will have to see in Sinatra how to do this. It has first class support. There's even an example in the Sinatra examples directory for doing server sent events that show you some state. I don't recommend copying that verbatim, but it's a good starting point. So unfortunately, the event source in JavaScript doesn't give you a way to provide headers as part of the request. So as a result, we need to pass the token in the URL. to create the particular stream. So this is a little weird, and this is definitely not recommended if you're not over HTTPS, because anyone can see these URLs. But we're going to do it anyway. In a full implementation, you'd probably have assign the user a short-lived token that they can use once to get the stream, and then they have to re-authenticate to get the stream again. Okay, anyways, so they get the signed token. The event stream begins and returns a 200, and then it starts streaming the event. So remember that this is going to create a long-lived HTTP connection. It will not end until the client disconnects or the server ends up disconnecting the user. If signed token is not valid, they should get back a 403, and the event source, your JavaScript part, should no longer try, it should not automatically retry. I think that should happen because this is an error. So curl -d base URL stream signed token, and then curl will actually keep the connection open too. So this is just a partial view of the response. So get 201 OK, and then the way it keeps the connection open and keeps going is this text event stream is a special MIME type that says keep the connection open. And then it starts sending server sent event formatted events. So each one of these, separated by 2 new lines, is a distinct message. This first one happens to be the user's message. The event is users, and then this is the message for that particular event type. All event types contain created, which is the timestamp, the Unix timestamp that event happened on the server end. And then the other attributes are things that are necessary for that event type. So user sends a list of users. Those are the users that are connected. Server start, server status, has a status and then a various message. Message always has a message field and the user, and we'll explain that, what all these types are. Every event has an ID, which is unique. They are not sequential in any way. I guess you can set up your event IDs however you want. They don't have to be done the same way I've done them, so they could be sequential, but they should be unique. No 2 messages to have the same ID. We'll explain that. So the events. There are 6 different event types that you need to handle. They should all have a JSON body. So that's the data field. This is the data field. And like I said, they should all have an ID, which is not sent inside the data because it's part of the actual class itself, or the stream itself. Okay, so the first event is disconnect. I have these sorted alphabetically. This indicates that the server is closing the connection. So the browser must close the event source so that it doesn't automatically retry. In particular, this is used in one place, which is a single user, I'm saying, can only have one connection to the chat server. So if I log in one window, I'll give you an example of this. Okay, and then if I duplicate this tab, note that it automatically logged me in here, but it logged me out here. So the chat is open here, indicated by the green. If I log back in here, I'm logged in. There's some redundant messages here because it's resending all the messages, but I got logged out here. So that is a requirement, and the way that is handled is the client gets sent a disconnect message. If you don't handle the disconnect message, the 2 of these will probably battle back and forth to keep trying to reconnect. That is not desired behavior. The join message should be sent anytime a user joins the chat. A message, sorry, these are events, not messages. I'm getting those confused. The message event indicates that a message was actually sent. So let me show you first join. So if I log in as a different user, So it says join curl. That user just joined. You can see that I'm keeping track of all the users in the system. And then if I log out, this doesn't have to happen immediately. So I'm going to refresh this browser. That user is disconnected. It's going to be a little while before the server recognizes that this user left. You could handle that by adding a new message if you want. Oh, there it goes, part curl. So that's the part message. So the server recognized that that client has been disconnected. So we have the message type, which is if I send a message, then that gets sent here. So that's not the client directly putting this in. It's actually receiving a message. Let me show you again, this time using the console, or sorry, not the console, the network. So if I refresh this connection and log in, and I click on login, and I go to, oh sorry, not login. If I go to the event stream, so this is the actual stream, you'll be able to see all the events sent into the system. So there is users, which gives me the list of users connected, including myself. There's the server status, which indicates server start. And then the server actually dumps all of the messages, not all of them, all the historical either service status or messages. So this is included server status, up to the last 100. It stores 100 events total, but only relays on connect, server status, and message event types. So if I join again as that other user, then we'll see the join message. And if I leave, or let me send hi. So we'll see that that came in here. So this is the raw set of all messages that are sent over the stream. And then your JavaScript actually has to handle those and do something with them. So that's message has created and who sent it. Created message and who sent it. The types are all listed here. And then the part indicates that a user has left the chat. So again, I'll close it and we should see that part show up probably within like 15 seconds. We'll come back to it. Server status indicates that the server is sending a message, not a particular user. And users is an array of strings which represent all the users connected in the system. And you'll get that on connect. So there's the part message. You could choose to send users more periodically if you want it to stay in sync. But in theory, if a user doesn't miss any messages or if a client doesn't miss any messages, they should be able to use that initial connect stream and then add and remove users as they join in part. Okay, server requirements. So those are all the messages that you have to support. Your server must maintain state about the users who are connected. Obviously, you need to be able to broadcast a message out to every user that's connected and be able to accurately send a list of users who are connected. When I say accurately, no users should be missed, and if a user sticks around a little bit longer than they're actually connected, that's okay. But you should have a way to detect that the user is no longer connected and clean them up. So parts should actually be sent. A join should be broadcast to every user. Once a user joins, a part should be broadcast to every user once a user has been detected to have disconnected. Every time a newly established connection occurs, the user's event should be sent. If a user sends a message, that message should be broadcast to everyone, including the user who sent it. This is what I explained before. Disconnect should be sent if a user logs in as a second client. The disconnect should be sent to the existing connection so that the new connection persists. In this particular case, there should be no join or part message because the user is still connected. They're just connected as a different client. When your server starts up, that's what this is indicating, you should push a server status message to indicate that it has started. That's the only really server status message you need to have, but you could add additional ones. You can have your server update the time or something as an added bonus. As I kind of mentioned already, you should maintain the history of the last 100 events. when a new user connects, they should, from this history of the last 100, be sent all the message or server status events. So no, don't send join in parts, but you should maintain those events in the event history. The reason why you should maintain those is because a user can lose their connection. For example, their internet could go down. When they get their internet back, server sent events should be able to send all of the messages they missed. So let's see. I don't have an easy way to mimic this. I can take the internet down, but I can't send messages if I take the internet down. So just note that that should happen. And the way that that happens is when it reconnects, server sent events, when it reconnects to the stream, will send the last ID of a particular message. And then your server will have to say what messages have occurred after that particular ID, and then send all of those messages that the client missed. And in that way, the server can be up to date. So that's why you need to keep track of all the messages, including join parts, because a client that's reconnecting after a period of lost connection should be able to obtain all the join in parts. Okay, so that's the specification there. You'll write a React front end, as I mentioned. And I am not really giving you, it doesn't need to look anything like this front end, and it can be a lot cooler, a lot better. But there are some things that you need to make sure that you handle. There should be a way to visibly discern between being connected and disconnected, like the presence of a login window or not, or in this particular case, the chat window, like the title changes between green and red, or the list of users online drops off. There should be some way to discern that. It should be easy to see who is connected, e.g. a list of users. In addition to viewing the users, I should be able to see when someone connected. So like my join, I can see that it happened at this time and make sure that this is in local time. Similarly, I should be able to see when someone leaves. So if you can display that however you want. I chose to display it in line with the messages, but that needs to be visible. Every new message event should be immediately apparent. So let me give you an example. So like somehow you have to highlight it. So this chat window is not full, so I'm gonna add some messages. Note how when I'm chatting, it's automatically scrolling me down to the bottom. That's the immediately apparent part. A message should not come in without me being able to notice it. Now I don't like that when I'm scrolled up, it pops down, but you should indicate somehow that, hey, there's a new message that you haven't seen. This is the most trivial way that I've found to handle it, is just scroll the browser down so that it's an alert essentially to the user that there is a new message. I should be able to locate and discover the server status messages. So this is, again, it's inline, so it's visible. Don't just hide those. I may update my server, probably so we can get more of these, to actually send a 10-minute timer or something to just announce the time so that we see more of these messages. This one should be pretty straightforward because event source, not event stream, I need to update that. Event source should handle this for you. But if, like, for instance, you have a network failure, the browser should continue to try to connect. This one I can simulate. So if I take off my internet and we look at, once it realizes it's no longer connected, hasn't done that yet. It's easier if I shut down the server, but it's not trivial to shut down the server. Okay, we'll come back to this. What we should observe is that it recognizes that it's disconnected and then keeps trying again, although maybe the browser's smart enough to not actually issue requests when it's not connected. We'll see what happens. Okay, so that's failing, but this should retry, but it has to like time out first. Okay, we'll come back. Disconnects, like, as I mentioned before, should not automatically attempt to reconnect to the server. And this one may be clear, but there should be no kind of black holes in your applications, in your chat front end, where I cannot take any actions. So like one example would be on disconnect. If you just disconnect me but don't give me a way to log back in, that would not be good. So I should always be able to perform an action. And as I showed, separate browser windows and or tabs should each be able to have their own connection to the server. Okay, that hasn't happened yet. Okay, I can't trivially turn this off. But as you will see, if you take down your server while you're connected to it, the client should continue to reconnect and automatically reconnect to the server when it starts up. It might not have a valid token because the token may be tied to the particular instance of the server, but that's up to you to handle. Within React, you deal with components, and so I'm specifying you need a minimum of 4 components. You'll probably have quite a few more, but one component can be your login form, your message list, your user list, and like your actual compose bar could be a component as well. So you'll need a minimum of those components, but I recommend breaking each individual piece out into more components. Okay, since many of you probably haven't developed using Docker, it requires a couple requirements like Node.js in order to run, and NPM. So rather than deal with trying to figure out how to install that, you're definitely encouraged to do so. But we can develop using purely Docker in a rather convenient way. So what I want to do is I am in a directory, project 3, so I'm already in it. And we don't even need to build a Docker container. We can just leverage the existing node container. And what we're going to do is mount the current directory into the app directory as a volume when we run it. So for instance, if I touch local file, just as an example, because this directory would otherwise be empty, and then I run this node application. So I already have this, so it doesn't have to download it. If I do ls, you will see local file here. And if I'm inside the container, touch Docker file or container file, and then I leave the container, we'll see container files here. So we've mapped this directory, so any changes we make in one will show up in the other. Okay, so let's go back into the container. Now this is a completely new instance of the container, so we're not maintaining any state in the container itself. We are completely tearing down and starting new containers. But all the files are local to it. So because we're using the node, we can run the npx command for create React app, and we're going to call it chat client. And that's going to take a few moments to run because it needs to download everything and build the node modules directory. So it's going to build a new one. This is where it installs the packages, and this part takes a little while. So we're going to come back to that in a little bit. So that creates the React app. Once it's done, we can start the server. And then what's really cool is we can make changes locally, like in our favorite editor. And when we save them, they'll automatically show up in the client itself. So we have to wait a little bit before we get there. So while we're waiting for that, I need to make this linkable. So I have a couple fixes to make in this document. This Hello World document has some good examples that you may want to follow through. And they link to, there's another document that you can link to, that this practice tutorial. But I would suggest starting here. So it talks about why JSX as an expression. Definitely recommend reading through this. Rendering elements into the DOM. I'm going to actually give an example. We're going to build some sort of application in class today. So I won't have any slides for today's lecture, but I'll make all the source code available that we create. So components and props, rendering components. So there's some cool stuff there. All right, this is still installing. It takes a little while when you create the app, the initial time, but the nice thing is that once it's created, it's quite quick. Okay, what else? So again, the hosted server example is chat.cs291.com. As I mentioned, that does provide a front-end interface. You do not need to serve your front-end interface through your server. You can if you want. So that's not a necessity. I just did that for convenience. But then there's a separate example, and here's the server. So there's a couple things I want to talk about in this particular server. So we have index.html. So I've written my server in basically pure HTML and JavaScript, which is quite a bit more cumbersome to deal with than writing stuff in React, because everything is in the same namespace, things collide, you have to manage state individually between like, oh, this action then affects this state. While the code may end up being simpler, or not necessarily simpler, but less code, it's so much more trivial to introduce a bug into pure JavaScript than React, which is the beauty of React. So this is my index page that is the front end. And so I have my container that has the chat window. And I give everything IDs so that I can then reference them and update them. And I have my login modal, which is always available on the page, but most of the time it's hidden except for when you're logging in. A little bit of CSS to style things to make it look the way it did. And then the meat of it is in app.js. Here is a function if you want to use to convert from the Unix timestamp that the server sends to a local time and string. Feel free to copy that. And then, so a couple of tools that you'll need to use are XML HTTP request. You can also feel free to use like the fetch module if you want. But to prevent forcing you to learn something else, XML HTTP request is how you can send data. So this is an example. You may be able to copy some of this. You just need to get it to work within your React component. You'll have to look up the specifics for this, but this says if the status is 201, then we're going to change some things, set the token and save it. And then I have like a trivial alert on invalid username or password or failure to log in. Okay, and then there's some things like this changes the class list. So this is, all this stuff is easier to do with in React. Like I have to explicitly set values, whereas in React, you just change state, which is nice, and the things happen for you. So the main thing is, here is the event source, and you give it a URL, and that's basically all the parameters that it takes. And then you add listeners, and so when you look up the documentation for event source, these listeners, you have one per event, and then a function for what should happen when that event is sent. If you don't add a listener for an event, you won't see that event. So disconnect, join, message, part, server status, users. The error event is when there is a particular error. And so you can decide what to do there. I delete the access token and show the login. You may want to do something else. Yeah. I think that's most of it. I have some stuff. So in pure JavaScript, I needed a way to say like when does somebody press enter? In React, that should be simpler, so you shouldn't have to listen for key up. And yeah, that's all there. Okay, let's go back to here. So the application has been created, and we should see chat client. So if we go back up in the tutorial, it says npx create, and then start the development server. So I'm already in the container, so I could just do it. But just to show you that it's purely stateless, I'm going to exit the container, rerun the container, which again is a new instance, cd into chat client, and then it says run yarn start. So this will start the development server. The first time it starts, it takes a little while, but subsequent refreshes should be fairly quick. And then I just want to show you how changes to the code show up pretty much immediately. So it's starting the development server. It'll say where you can access it from once it's started. So like I said, it takes a little while to first start, but then you can basically just leave it open and not need to restart it while you're developing. By default, it should show up on localhost 3000. I know 3000 is what we were using in the Ruby Sinatra app too, so you may need to change one of those local ports to work. So here is the templated React.js app. And so now, if I'm in the wrong directory. So this is local, not inside the container. If I edit source app.js, so this is very small, but let's just say I make a change like let's say instead of edit source, I say hi class. Indent it just to look good. And I save, you'll see that it rebuilt here and now it says hi class. So I didn't have to refresh anything. I literally just go in, this is an update, and I'm saving. It's rebuilding, and then the browser automatically gets that update. So this is a great way of quickly getting set up with React development that doesn't require you to install any dependencies other than Docker. And with that, I think we are done. Let me just quickly review. Acquired tool. So the references for cores, Docker, JSX, event source are all here. In high performance browser networking, they happen to have a chapter each for server sent events and XML HTTP requests. I recommend you read those to give you some context about speed and performance using those particular things. And happy hacking.